Welcome to Land Navigation for Search and Rescue. This video is part of a series designed to assist SAR volunteers in acquiring skills essential for safe, effective land navigation in a search and rescue environment. The videos for map reading, compass work, and GPS operation are designed to address Washington State's land navigation core competency requirements for ground searchers. Compasses are used to establish directions, and they are used to measure directions. For search and rescue, directions will be defined using true azimuth. The direction between 2 points is a straight line running from one point to the other. Direction is defined using the true azimuth of this line, which is 70 degrees, and is determined by measuring the horizontal clockwise angle from a true north reference line. Compasses are used to establish the north reference and measure the angle. Azimuth is the technically correct term. However, I am finding that many in the search and rescue community use bearing instead. The bearing to your checkpoint is 47 degrees. For this video series, let's define bearing equal azimuth equals direction. And you can choose which term works best for you in your SAR community. Essential elements of a compass include the magnetic needle. The red end of the needle points to magnetic north. The index pointer, and this is where you read or you set the direction. And the azimuth ring or basal, which is graduated in 2-degree units usually, though some are 1 degree and some are 5 degrees. But the graduations increase in a clockwise direction. A compass needle points to magnetic north, which is located in northeastern Canada. The angle between magnetic north and true north is known as the magnetic declination. The magnetic declination is constantly changing. The magnetic needle will point to magnetic north if the compass is held level, the needle moves freely, and is not being influenced by magnetic objects such as a watch, a belt buckle, power lines, or a vehicle, etc. Note the sight and sighting lines of the compass. The orienting arrow is used to properly orient the compass. The azimuth ring or basal is graduated in 2-degree units in a clockwise manner and is used to measure directions. There are 2 ways to orient a compass. One is to rotate the azimuth ring or basal, and the other is to rotate your body and the compass to the direction to which the compass is set. When the compass is oriented, the magnetic needle will be centered in the orienting arrow. Box the needle, or red on red. The declination diagram on your map may show 3 north references: true north, magnetic north, and grid north. In search and rescue, we will always use true north as the reference, so our directions will always be defined using true azimuth. Magnetic declination changes with time and location. So it's a good idea to check on the current declination for your area every year or so. This compass is pointed to magnetic north. An azimuth of 360 is aligned with the index pointer. The magnetic needle and orienting arrow are aligned and parallel with the meridian lines. Declinating your compass. Go online and get the current magnetic declination for the area. Use the adjusting screw to move the index arrow in the proper direction. For a 20-degree east declination, move the index arrow as shown. This compass is pointed at true north in an area where the magnetic declination is 20 degrees east. Azimuth of 360 is aligned with the index pointer. The orienting arrow is set 20 degrees to the east of north, and the magnetic needle and orienting arrow are aligned. Box the needle. When a compass is declinated, the orienting arrow is not parallel to the meridian lines in the base of the compass. In this example, the orienting arrow is set for a 20-degree east declination. Directions measured using a declinated compass are automatically converted from magnetic to true. True directions are the framework for most maps. SAR directions are defined using true azimuth. Why worry about declination? Because all error in setting the declination is a built-in error for all of your directions. Incorrectly set declination is a common problem, and searchers tend to assume that declination has been correctly set, or they don't even look at it. A mirrored compass is being used in the examples for this video. However, base plate compasses such as these are entirely adequate for SAR operations. Compasses with longer needles and a mirror can produce greater accuracy when used correctly. Your compass may have an inherent bias, a defect in construction. Always check your compass against a line of known direction. You can do this by plotting a true north direction on your map, and then take your compass into the field and measure the direction of that line. If your compass is properly declinated and you do not read true north, you have a defective compass. Buy a quality compass. Test it out in the environment you expect when you are searching. Buy a compass that can be declinated. Common errors in using a compass are not holding the compass flat and level, incorrectly reading the azimuth ring. Don't forget that azimuth increases in a clockwise direction, and the compass is not properly sighted. Be especially careful when you're using the mirror. For mirrored compasses, use the sighting line in the mirror. Be sure to align the sighting line with the index pointer and the pivot of the magnetic needle. The mirror should be opened about 70 degrees or less to the base plate, and the compass should be level with no local attractions. Using a compass should be a field-oriented training process, so take your compass and get outside. To measure a direction with your compass, face the direction you want to measure, sight your compass on the direction, rotate the azimuth ring or bezel, and box the needle. Read the direction at the index pointer. Most field compasses have 2-degree graduations. Remember to read in a clockwise direction. The index pointer is where you read or set a direction. To measure or establish an accurate direction, all these points must be in the same straight line. The base plate must be flat and level. To establish a given direction with your compass, turn the bezel and set the direction at the index pointer. Rotate your body and the compass until the magnetic needle is centered over the orienting arrow. Box the needle, or red on red. Set the direction on your compass. Hold the compass flat and level and rotate your body until you box the needle. Sight down the sighting line and pick a target to walk to. Using a series of shorter intervals is recommended. If your compass is set correctly, sighting errors will tend to cancel out. Rotate the map and the compass together until the compass is oriented, pointed to true north. Make sure the true north reference line on the map is parallel to meridian lines in the compass. To measure the direction from A to B, you must first establish a true north-south reference line. And don't forget to make an estimate of the direction as an error check on your work. Place the compass on the map and align the edge of the compass with the direction you want to measure. The sight line should point in the direction you want to measure. Turn the basal until the meridian lines are parallel to the true north reference line on the map. Make sure your compass is properly oriented. Read the directions at the index pointer. Set the desired azimuth at the index pointer. Rotate the compass around the point until the meridian lines are parallel with the true north reference line. Draw in the line parallel to the edge of the base plate. Locating your position by triangulation involves plotting the back azimuth from two known reference points on your map. The compass should be opened so that the mirror is 70 degrees or less to the base plate, so you can see the magnetic needle and the sighting line in the mirror. Be sure to align the sighting line with the index pointer and the pivot of the magnetic needle. The compass must be held level and there should be no local attractions. This part of your training should include field experience. Proper use of the mirror will enable you to achieve the maximum accuracy from your compass. Correctly centering the needle can be tricky. Take your time. Make sure your sight lines are correct. Using a mirrored compass takes some practice. Hold the compass at arm's length. Hold the compass level. Fold the mirror as needed to get a good view of the needle and the sight line alignment. When viewing the needle from the side, take your time to ensure it is centered in the orienting arrow. Using the sight lines and the mirror maximizes the accuracy of your compass. Read the direction from the index pointer and be sure to use the north end of the needle.